Welcome again to this YouTube channel PGK Kadam Academy. Dear friends, we are watching the vibration measurement videos. Under this video, frequency measuring instrument we are going to learn very fast. Various parameters we are measuring under the vibration measuring instruments. Displacement, amplitude measuring instrument vibrometer is there. The velocity measuring instrument velometer is there. And after that, acceleration measuring instrument accelerometer is there, and frequency measuring instruments are there. Dear friends, all the videos of separate on each individual parameters we can watch on the my YouTube channel playlist. Dear friend, frequency measuring instruments are of mechanical type and based on one of the principle, that is the principle of resonance. What is principle of resonance already you know, but for revise, it's a phenomena that occurs when an object or system is subjected to an external force or vibration that matches its natural frequency. When the natural frequency it matches with the frequency of that object, then the resonance is occur. We'll see through this experiment. See here, 512 hertz and 440 hertz. There is no, even though frequency is more, there is no resonance will occur. When the same frequency were attached here and were done the vibration, see resonance is occur. That we can observe through this video. Dear friend, that due to the resonance, ball is moving. That vibrating the York, the another York is vibrating with the same frequency. So dear friend, these are the separate types of the frequency measuring instruments are there. Based on this principle that are working, there is a single read frequency meter or Fullarton tachometer, multi-read frequency meter, Frahm tachometer, and third is the stroboscope. Generally, it is used for the measure in industries, and you can watch the separate application of stroboscope video. Dear friends, single read frequency meter or Fullarton tachometer. Here in this figure, you can watch the construction principle technique and where its equipment is used. You can see here in this figure the construction of this single read frequency meter. We can see here the mass is attached at one end and the strip, or we can say the reed is there, is fixed on this vertical by means of the screw, and one free end of strip which is pressed over the vibrating body. The free or the cantilever length of strip or reed, you can say the L, can be changed by means of screw mechanism. Therefore, each free length of strip or reed correspond to a different natural frequency of strip. The different free lengths of strip, the strip or reed are calibrated for natural frequencies. The screw mechanism is adjusted to change the length of strip till the amplitude of vibration becomes maximum. At that instant, the excitation frequency of vibrating body is equal to natural frequency of strip, that is resonance condition occurs. Since the reed is calibrated along its length in terms of natural frequency. The frequency of vibrating body is read directly from the strip length. Okay, that calibration, that technique is used in industry. Similar way, the multi-read frequency meter or Frahm tachometer is there. Here, see the construction principle of working technique to find the frequency and where this equipment is used. See here, in multi-read, what is the difference? There is a number of reeds are there or strips are there, but vertically placed here. You can see the side view of this reed, and these are the number of reeds are there. Here, mass is attached on the each reed or strip, and top of the mass is there, and you can see the side view here in this diagram. So friend, here what will happen, multiple read frequency meter or Frahm tachometer, it is also called as Frahm tachometer. It consists of number of strips or reed in the form of cantilever, carrying small masses at their free end. Each reed has a different natural frequency according to mark on it. And when this instrument is mounted over the vibrating body, whose natural frequency is to be measured, the reed whose natural frequency is nearest to the excitation frequency of the vibrating body, it will vibrate with the maximum amplitude due to resonance condition. Therefore, the frequency of vibrating body can be found from the frequency of that vibrating reed. You can see this is actual the reed. These are the mass attached here. You can observe which is vibrating that near to that frequency. This is the actual diagram of that multi-reed frequency meter. It's a passive type. There is no electricity there. Based on the resonance principle, it working. That vibrating that reed, this reed will vibrate, then frequency becomes 50. So we can say the frequency is 50 hertz. So this, whatever the different types of the multi-reed frequency meter are available according to the your requirement. Next is the stroboscope. Dear friend, stroboscope is a very essential instrument which produces a light pulse at equal interval of time, which can be varied. The frequency here construction, you can see the principle of working, technique to find frequency, and where this equipment is used. That we're going to see here. The frequency of light pulses which are produced can be changed and read easily from the control panel instruments. Here, what will happen when a reference point on a vibrating body is viewed with a pulsating light, which is generated by the stroboscope. The stroboscope will give the flashing light and it will put on the vibrating body. So we can see the frequency of vibrating body. Therefore, frequency of vibrating body is read directly from the control panel. The advantage of stroboscope is that it does not have any contact with the vibrating body. Hence, it is non-contact type frequency measuring instrument. The lowest frequency up to 15 Hz can be measured easily with the help of stroboscope. As shown in figure, how its construction is there. You can see here, and we see the application of the stroboscope. See here, what is the here in the top figure? This is the belt drive. Here it is mark is given on the for draw reference line across all the belts. When we restart the machine and observe the reference for this here line is draw here for reference line. When we observe the reference line, if the alignment is good, the line should be remain pictured. When alignment is bad, that will be here. It will, you can see in this picture, the stroboscope observe the vibrating. The lines are vibrated. That means exact running speed. Flash the stroboscope tuned to exact running speed. As in the above figure, the outboard belt is pulling the load due to the misalignment. The mark can be seen at the running speed. Each progressive inboard belt is slipping, and the marks lag behind the move slower than the running speed. Similar way in this diagram also you can see, if we done the chalk mark on this belt drive, you can see here which is rotating at the clockwise direction, and here the stroboscope is there. What is the function of stroboscope here? As the machine runs, tune to running speed, slightly detune the stroboscope and view the belt profile. If the pinhole shape is observed, then check alignment. You can directly, the stroboscope will be give the detection of that pinhole shape, and that shape will change. We can check the alignment also directly. It will be the automation we can apply to this type of the belt drive. See here, this is another example of the belt drive application of the stroboscope for the belt drive. Here also the actual running, the shaft is running with the speed of RPM 1500 RPM, And what will happen due to the misalignment, the actual running speed, when it will come to the 3000 rpm, what will observe maximum displacement of wobble. The wobbling is observed by the stroboscope, and that will be detected through our display panel, and we can do the necessary action, preventive maintenance we can do it. These are the industrial stroboscopes, which are bent stroboscopes, are there, high brightness at any speed you can measure. These are the actual stroboscope available in industries. So friends, if you are not subscribed or shared my channel, please subscribe, like and share my channel. Thank you very much.